Alright, let's look at the properties of continuity. Right? So let's say if you have two functions, they are continuous at A, then any algebraic combination, for example, f plus g, and some constant times f, or product of two functions, right? And also f over g, right? This one you have to be careful making sure that g of a is not equal to 0, right? And these guys are all continuous, right? So if you have two functions that are continuous, addition, subtraction, constant multiple, product, and division, the resulting functions are always continuous. All right, and composition is pretty much the same way, but let's say g is continuous at a, then f is continuous at the g of a, then we know that f of g is also continuous, right? And the third one, following functions are continuous on their own domain. It's actually almost all the functions that we know of. For example, polynomial. Right? Polynomial functions are continuous everywhere because the domain of polynomial function is all real numbers, so it's continuous everywhere. And rational functions, right? And also root function and trig function and inverse trig function and exponential function and also log function. Those functions are all continuous on its domain. So if somebody asked where would one of these functions continuous, then all you really have to do is look for its domain. Alright, so let's look at the example here. Alright, so let's find find out where this function, this given function, is continuous. Alright, but this question is really the same thing as find the domain of this function, right? So let's look at this. So since you have a natural log of x, right, this tells you that we know that x have to be positive, right? So first condition would be 1, right? X has to be greater than 0, right? And here there's an arctangent. Right, arctangent is actually defined for every real number, so it actually doesn't give you any restriction the x value. Right, but here, from here, we know that we have to make sure that the denominator is non-zero. So if you factor it out, it's x plus 2 times quantity x minus 2. This guy has to be non-zero, right? So this tells us that there's a second condition, is that x cannot be equal to positive 2 or negative 2. Right? And those are the only two restrictions, so we have to combine those two. So combining 1 and 2, so x has to be greater than 0. At the same time, cannot be 2 or negative 2. Negative 2 is already kind of eliminated by the first one. So therefore, we know that f is, right, f is continuous on the domain. So it's going from, let's say, from 0 to 2, right? Then we have to skip 2, right? Then also on 2 to infinity, right? So that's the domain of this function, which means that this function is continuous on the domain. All right, that's it. I hope that this was clear.